Two heads are better than none. How is this related to addition reactions? In this objective, we'll look at alkene addition reactions. We'll look at the relevant structural features in an alkene and how it reacts with an electrophile. In an addition reaction, an alkene reacts with reagent XY. In the addition product, note that X and Y adds to each vinylic carbon. Alkenes undergo addition reaction because the carbon-carbon pi bond behaves like a nucleophile. So an alkene addition reaction is a good way to add a functional group. And as a result, alkenes are used as starting materials for many different compounds. For example, an alkene reacts with HX, which could be HCl or HBr, to form an alkyl halide. An alkene can also react with water using an acid catalyst to form an alcohol. Ethylene is a very important industrial chemical, and it is used to make many different functional groups. The compounds that are made from ethylene and propylene are used to make many of the consumer products we use. In an addition reaction, a pi bond nucleophile reacts with an electrophile. The pi bond breaks to form a new functional group. Note that the atoms or groups in the electrophile add to each vinylic carbon. So the structural features that are needed for an addition reaction to occur are a nucleophile, which is the pi bond, and an electrophile. So let's use curved arrows to show how bonds break and form. The nucleophilic pi bond reacts with the electrophilic H to form a carbocation intermediate. The nucleophile reacts with the electrophilic carbocation to form the product. Another type of carbocation intermediate can form, so stop the video, draw the carbocation. The other type of carbocation that forms is, note that this carbocation is a primary carbocation which is not stable. Alkene addition reactions are polar reactions, so let's take a look at a general alkene addition reaction. Stop the video and fill in this blank. And the answer is, when propylene reacts with an acid, either HBr or H2SO4, carbocation A or carbocation B can form. So stop the video and fill in this blank. And the answer is, the stability of the intermediate determines the product. This is known as Markovnikov's rule. So let's practice. Stop the video and predict the product of each reaction. And the answers are, an addition reaction is the reverse of an elimination reaction. Let's take a look at this reaction energy diagram. Stop the video and answer this question. Which reaction requires high temperature? And the answer is, the elimination reaction has a larger activation energy than the addition reaction. To overcome that large activation energy barrier, the elimination reaction requires high temperature. Let's practice. Stop the video and predict the product of each reaction. Limonene is the substance found in lemons and oranges, which gives those fruits its distinctive flavor and taste. So here are the answers. Another product can form, and for the reaction of limonene plus sulfuric acid, the products are. Practice using those curved arrows to show how those products form. We learned earlier that the stability of the carbocation intermediate determines the addition product. If you want to add an alcohol or halide to the other carbon, you have to change the reaction conditions. When you add the alcohol or halide group to the other carbon, that's called the non-Markovnikov product. To add OH to the other carbon, we have to use these conditions. That's called the hydroboration reaction. Starting from propylene, the mechanism on the right shows the Markovnikov product. Going to the left, BH3 is an electrophile. Stop the video and try to figure out which intermediate is formed. The answer is due to steric effects. And the non-Markovnikov product is 1-propanol. If you want to add Br to the other carbon, you have to do a radical reaction. We'll look at the radical reaction mechanism later on in this course. So starting from propylene, going to the right is the Markovnikov addition product. Going to the left is the radical mechanism which forms the non-Markovnikov addition product. Alkene addition reactions are used to make different function groups, so let's practice. Stop the video and identify the reagent you would use for each reaction. And here are the answers.